Hi, Phil from statisticsmentor.com. So now we're almost experts at computing probabilities of a win in a lottery and able to tell our grandma it's a waste of time. Let's look at another way of solving this. A way that I see students do this. I get this answer every year. So 20 balls numbered 1 to 20 will win by matching 5 numbers which are drawn without replacement. Here's an argument that the student makes. Okay, well, the first ball is out of 20. And I'm drawing one ball because it's one of the winning balls, so I write 1 over 20. Now there are 19 balls. Out of 19 balls, I'm drawing one because one of them will be the winning ball. And then now I'm going to do 18, and one ball will be a winning ball. I think you can see where this is going. Like that. You get that? Okay. Well, it's wrong, isn't it? Question is, why is it wrong? If you can explain it, it means that you understand this problem. Let's explain it like this. Say that I want a different color. Say that we win the lottery if we get the numbers, the following numbers. Or let's just call it 1, 3. What's your lucky number? 13. 1, 2, 3, 4, 5. And it must be in that order. Then we can say that the first ball, it must be a 1, and you've got 20 balls, so that's 1 over 20. Now you've got 19 balls, but out of 19 balls, it's got to be a 3, otherwise you're not going to get a win. So you've got 1, and so on. So does that explain why this is wrong for our problem? Yes, because the answer you've given here is probability of a win if the order of these balls matter. Because using the definition of probability, number of events I'm interested in divided number of possible outcomes. The first one, number of possible outcomes is 20. Above there, number of balls that is in the event. Well, there's only one because it's got to be this number. Can't be any other numbers. In the unordered case, where we don't care about the order of these numbers, the first case is 5 because it can be any 5. Yeah, so it's a case, I think, when students do this, they're not thinking about up here about the number of possible outcomes. They're just thinking here about, oh, how many am I drawing? Well, it's true you're drawing one ball, but that's not what number should appear here in the numerator. Supposing it was the case that the order matters, then we can see that only one way of winning, because it's got to be in this order, so number of outcomes winning ways is 1 out of the number of possible outcomes. Well, if order matters, we're using permutation, aren't we? It's 20. From 20 we're drawing 5, and 1 over that gives us this answer. So there you go, I've answered the question why multiplying probabilities like this, 1 over outcomes, doesn't work. Also, if you haven't watched my other video as well, I point out why multiplying these probabilities could be a dangerous thing unless you know what you're doing.